All right, want to wish good afternoon to all of our attendees here for the IP Audio Network webinar from APT WorldCast Systems. My name is Tony Peterly. I'm the manager of APT WorldCast Systems office in Miami, Florida. With me also on the broadcast today will be Kevin Campbell, who is our worldwide director of sales for the APT Codec products. And we're going to be talking a little bit about IP audio networks, how to get IP audio where you need it to via IP, and how to create networks that are resilient to the changes and the demands of network audio transport. So we're going to tell you first a little bit about how to deal with the webinar. There's a panel over on the right-hand side where you can interact. We've got all of the viewer microphones muted at the time being. Y'all are in listen-only mode, but that panel on the right is a place where you can adjust your mic and speaker settings. If you're not hearing audio, that would be a good place to go right now, although you can't hear me tell you that. You can ask questions. We're going to collect the questions during the course of the webinar and answer as many as we can before we sign off here at 1 o'clock this afternoon. We are also making a recording of today's session, so that will be available after we do a quick review of it. It will be posted up, and we'll have links available so you can download the recording and share with people who were not able to make it today. Also, we have some handouts available. We're going to be talking about a couple of products today and some technology, the SureStream technology. And so we've got the data sheets for all the products that we're going to be discussing, and also that essential guide for AOIP for broadcasters. That's a really useful book, just 70 pages of just very hardcore information about, just the details of packetization of audio, from very basic concepts to some more advanced topics. So it's a very useful guide for anybody who's working in the audio over IP realm. All right, one more housekeeping item here before we move on. We would like to invite you to visit us at NAB. Yep, less than 2 weeks away. We're going to be there at NAB. We are in the North Hall, the one closest to the hotel that used to be the Las Vegas Hilton. We call that the Radio Gulag now. We're up in the North Hall with all the rest of our radio friends, booth 6134. So if you're coming in the doors from that Las Vegas hotel, you would turn to your right or to the west, so just west of the main pathway from those entry doors to the main halls. And we hope to see you there. We've got appointment books open now, so if you want to contact us via phone or email and set a specific time so you can guarantee, but of course, we're going to have everybody there. Kevin and myself will be there. Christoph, our worldwide sales manager, is going to be there as well. We also have key members of the research and development team that attend NAB every year. So it's a great idea to talk about future features and ideas and suggestions, and really share some knowledge back and forth. One of the things we really appreciate about going to NAB is that ability to really interact directly with our customers. We are demonstrating some really neat new stuff. We've got a brand new 10 kilowatt high efficiency FM solid state transmitter from our Acrizo transmitter division. We're showing that off at NAB this year. Really exciting product, should be shipping a little bit later on this year. We also have a new remote control product. Many of you are familiar with our Relio product that was used by Clear Channel and EMF and many other engineers. Well, we have an in-house replacement for that, a product that we've designed ourselves. It's going to become part of our regular product line, and we're going to be showing off the first examples of that at NAB as well. Also, a new software product called the WorldCast Manager. We're very excited about this. It is basically an open source SNMP management device. A lot of talk about SNMP. We're going to talk about SNMP a little bit later on today as well, but it is an extremely useful protocol, and we have a new piece of software that allows you to monitor, keep track of many devices from any manufacturer via SNMP and coalesce all that status information into one centralized window. It's a very useful tool, and the neat thing about it is it's free to try. So also a big party on Tuesday evening, 5 p.m. Come on by. We're going to have some proper beverages to celebrate 60 years. Our transmitter division, I mentioned Acrizo, has been building transmitters for 60 years, which is a really long time. They're proud of that, and they make some really excellent transmitters. So we're happy to have you all on the booth on Tuesday evening if you want to stop by for some drinks and entertainment and celebration. All right, so we're going to move on here. The Ultimate IP Audio Network. What is the Ultimate IP Audio Network? It is combined of many things. Of course, first off, the network itself has to be highly resilient. The first step you have to cross off in order to call it an IP audio network is to get audio from one point to another via an IP network. So it's got to be resilient. It's got to be self-healing. It's got to be inherently redundant. And to go beyond that, it's got to be intelligent and self-aware and self-governing. I did a presentation on network security last year in Columbus, Ohio for the Ohio Broadcasters Convention, and the watchword that came away from that is there is no such thing as static network security. Well, it's the same thing for an IP audio network. You can set up static routes that are going to work, 90% or 95% or maybe even 99% of the time. But no network is perfect. So the ultimate IP audio network has got to be aware of changes and problems in the network and be able to adapt and overcome those issues. So one size fits all is not a concept that applies to IP audio networks. So it's a question about picking out the right tools, identifying the challenges, and developing your IP audio network a reality. Primary among those is redundant streaming. Like I said, job one is to get audio reliably from point A to point B. So we're going to talk about how to surmount that obstacle with particular focus on a customer Rhode Island Public Radio. Then we're going to talk about this in distributed intelligence, the fact that the codecs can have a little bit of brain power in them as well. They can detect problems with the network, they can communicate and control one another, so that allows them to adapt and change routes and things. Packet forwarding is also a very useful concept when it comes to developing resilient networks, and we'll talk about a project we did last year with the NBA that highlights the packet forwarding features. And then, of course, multicast and multiple unicast and being able to relocate nodes to distribute programs in ways that can reduce your overall program line costs if you're doing a big distribution project. So those are basically the places we're going to touch on. And like I say, we're starting with redundant streaming. So this is a software option that was made first available on APT audio codecs about 4 or 5 years ago. We have, I think, well over 1,000 of them operating in the field. What it does is it basically guarantees flawless or very near flawless audio transmission over unmanaged IP networks, including microwave, satellite, DSL, cable, public internet, private networks, doesn't matter. It also brings with it inherently a couple of nice features, and that is the latency on the link. In other words, the latency on the link is not increased by any significant amount using this redundant streaming technology, and the delay, the play-out delay from where the audio goes in to where the audio comes out the other end, that stays absolutely constant, and that's very important when you're trying to hit network queues, top of the hour insertion of local content and that kind of thing. So the constant delay is an important concept, and of course balancing out the big swings of jitter that are inherent in an IP audio network. So we hit on this concept, like I say, several years ago, and it seemed really very simple and like it could be very effective. If you're seeing the animation, you can see we're sending basically 2 copies of the information. Belt and suspenders approach, you could call it. One copy of that stream is going by one route, another copy of the stream is going by another route. Any packets that are missing from either one of the streams are automatically filled in by packets from the other stream, and that's all done at the packet level. All those streams play out, dump into the same buffer, and the audio stream is reconstructed with the packets from that buffer, no matter which path they came in on. So the neat thing about SureStream is it's functional even on a single network connection, and we have many customers using this. We have a product, the stream in, stream out, the silver, what we call the IP encoder, decoder, just has a single network connection, but given enough bandwidth, of course, you can send redundant streams on that single network connection, and that can go a huge amount of the way towards protecting that network connection and making that audio reliable. We've seen packet loss reliabilities up to about 5 nines, 99.999% reliability on a single network link, so that's pretty darn decent. Of course, you're not protected against a loss of connection event, but still, even on a single port, SureStream could be quite effective. However, if you really want the Mac Daddy button down, be all, end all, will always stay connected no matter what, then you want to look for 2 network connections on each end, and preferably from divergent technologies. If you have one ISP that's a DSL, try and find another ISP that's cable. If you have a fiber path, maybe put up a microwave hop if you can. You can even use 4G, you could use satellite. And one of the concepts of these, if you're working on public IPs, right? You can send audio across the public internet, so all of these interfaces could have public IP addresses. So of course you could stream from port 1 to port 2, or port 1 to port 1 and port 2 to port 2, and that's fine. But again, given the bandwidth to upload multiple streams from each of these ports, you could also stream 2 streams from each port to both of the ports on the other end. And that way, even if you lost any single DSP, if you tripped over a network cable or one of those network ports on the equipment happens to go bad, which doesn't happen, but, you know, say somebody pulls the plug on a switch, you could lose any one of those network connections and still have redundancy, either single source to dual reception or vice versa at the other end. So a great way to build even more reliability. So lots of advantages to this redundant streaming concept versus the other methods that have been used in the past to cope with lossy networks and trying to get near real-time content across lossy networks. Chief advantage, and, you know, I mean, we're talking about radio. We're doing other things than radio with this, but it's primarily the technology was developed for audio. So the first thing we do is not screw up the audio. You can use any algorithm, whatever the bit rate is. You can even send composite signal, analog or digital composite. It's a consistent audio quality, consistent play-out delay. So the first thing we do is we get the audio there reliably and intact. There's no changes in bit rate or bandwidth or the audio quality ever. Second advantage, you can use any kind of network bandwidth, be that DSL, microwave, cable, cellular, satellite, doesn't matter. Like IT connections, you've got the advantages still of being able to send to multiple destinations with multiple Unicast or Multicast. If the network permits, you can send to multiple destinations. So you get that scalability that comes with an IP infrastructure, so it's useful. The redundant streaming doesn't add any additional delay on the link. Other techniques, noticeably forward error correction, can really increase that audio in to audio out delay. And like I mentioned, it's totally scalable. So on a single network link, this redundant technology can approach 5 nines or better. On dual network links or multiple diverse links, performance approaches perfection. Now we say approaches because nothing is perfect, but let me tell you what I'm talking about here. We have a link that we established way back 5 years ago for testing this redundant streaming technology in the real world. We got both inexpensive DSL and cable internet connections on both ends. We're sending audio, bidirectional stereo audio using the enhanced aptX compression algorithm. I think our bit rate's running about 350 kilobits per second per stream. We've got less than a second of buffer. And we've been running this off and on and, you know, amassing some statistics and using it for software updates and testing and try a little of this and a little of that for diagnosing and helping customers set up their issues and test their links. But back in August of last year, we decided, all right, let's just leave it alone for a while. Let's just set this up. We're just going to let it run like a customer would let it run, and we'll see how long it takes before we lose a packet, one single packet of audio. We went 160 plus days with no losses. So you can see the network information down here below. You can see the individual streams. We're sending 4 redundant streams from Belfast to Miami. Each of those streams has delivered 350 million packets plus. You can see the events, the drop packets on each of those individual feeds, numbering in the tens of thousands. You can see the loss of connection events on each of those 4 feeds, numbering in the hundreds or thousands. Any one of those drop packets or LOC events could have been an audible problem on a single path link, on a traditional IP codec link. Any one of those drop packets or LOCs could have made a blip that your listeners could hear. But SureStream soldiered on. It recovered from all of them, 160 plus days from August of 2015 till February 8th of this year, 0 losses. So we thought to ourselves, hey, we'll just let this run on till NAB. We'll have even more impressive stats at that point. Well, best laid plans sometimes don't work out for us. 9 days after I took that screenshot, we had 3 tornadoes hit the north end of Dade County, knocked out our power for the better part of 24 hours. And that outlasted our UPSs that I had on that link. And so even though the pathway was still there, I just didn't have enough power to run the codec. So we had to reset our stats. So since then, we have lost 1 packet. This is about 100,000 or 100 million packets, so roughly 50 days of operation. since February the 17th, 40 days of operation. We lost one packet. We had a situation where our network firewall here at our office actually crashed for a day. So for an entire day, we were running on just the DSL link and not the cable link on this end as well. So sometime during that day, the DSL hiccuped and we lost a packet. So c'est la vie, as they say. Still extremely useful and very reliable technology. So customers, of course, have been adopting this. Cumulus is one of the first big ones. They put in this link for Michael Savage between San Francisco and New York City using SureStream, and they're using part of their corporate MPLS network. The other leg of the other redundant stream is on DSL. So they're quite happy with the audio and the closures they're getting to New York City. They have since added links to bring in their Nash FM audio from their studios in Nashville, and also Robin Mead from CNN in the mornings does reports for them, so they have an audio feed from CNN in Atlanta to their studios as well, also on a SureStream link. We also did a deal a year and a half or so ago with Mood Media, big provider of background music. They were the company that absorbed Muzak and DMX a few years ago. They're sending 120 plus stereo feeds using SureStream from their origin point in Fort Mill, South Carolina, to their distribution sites in Denver, Cheyenne, and Raleigh. They're working on expanding their network as well. We've had a lot of business from CBS Radio, ESPN, iHeartRadio, EMF, WNYC in New York City. So lots of happy customers. So we decided this redundant streaming technology was so effective. What if we could give customers the option to apply that to an existing IP codec route? So this is the SureStreamer that we introduced, won a bunch of awards last year at NAB. This is basically a stream relay. It's a duplicator, replicator, and forwarder of streams. So this can receive a stream from an existing audio codec or some kind of codec and create copies of that stream and forward the copies via multiple paths through a lossy network to another SureStreamer on the other end, which coalesces those multiple streams down into a single one for the playout. So a neat idea, and the first customer to adopt it was Aaron Reed, WNRI, really when the units were still sort of a beta. He got a pair of them at his situation in Rhode Island. He had an existing schema. He was using an equalized primary Verizon program service line, 15 kilohertz equalized line. That's a I can't remember the last time I could order one of those. I used to have those long time ago. And as a backup, he had a pair of IP codecs over Cox cable modem, and Verizon DSL had a kind of a load balancer splitter. Wasn't the most reliable setup that he had. And then Verizon decided to pull the service, that program audio service, that equalized line, in March. So they decided to go with the SureStreamer. Since they had existing redundant ISPs and existing IP codecs, and the cost was competitive, and they knew the SureStreamer technology because they had some colleagues nearby that were using just a regular APT IP codec for STL. So that's a little chart of Aaron's facility. We won't go into a lot of the details. If anybody is going to be at NAB, or actually pre-NAB, for the PREC, the Public Radio Engineering Conference, Aaron and I are actually going to be doing a more detailed presentation on this at that public radio conference just before NAB. I believe it's on the Friday afternoon before the NAB starts. So Aaron, quite happy with the performance. Does well. It's smoothing over the issues that are common to those types of ISPs. Even enterprise fiber can have downtime. Cumulus found the same thing on their MPLS network. You know, even the best networks will have downtime for maintenance, and even the best networks sometimes have downtime that's not planned. So Aaron suggests tracing the redundancies carefully. You know, for example, if the cable and the DSL line are both on the same telephone pole, and that pole is knocked down, you're going to lose both your paths. So it's something to be aware of. And overall, he says the SureStreamer is a powerful tool. It's a network device, but as such, and because it is adapting and adjusting and accommodating what the other IP codecs are doing, it's a little bit more complex to set up as opposed to just a straight IP codec that has the SureStream technology built in. Okay, so that's redundant streaming, and as I've said in several of my presentations around the country in the last couple of years, we can consider the issue of transporting audio reliant on a network to be solved. So the next big building block in the ultimate IP audio network is the intelligence, and for that we have our ScriptEasy control software. This has been running in our products over on the Automat side of our product lines for many, many years. It's a very powerful graphic software that allows you to configure and connect things in a visual realm so that you can retrieve information, you can take readings, you can check sensor inputs, you can trigger relays, you can send commands. That software, that ScriptEasy software with all of its power, is included at list price, not an option. It's included in most of the APT codecs, pretty much all of the newer generation, the IP codec, AOIP boards, and the silver encoder and decoder. So ScriptEasy can control the codec that it's running in. It can control other codecs and devices through SNMP or even through GPIO. There are some relays and GPI built into the codecs, and through SNMP and serial interfaces they can control other boxes with GPIO as well. So there's a lot of power in there. The ScriptEasy can be taught to evaluate conditions and perform automatic actions. Those can include changing a profile, activating a backup stream. It can also alert staff via email if there's a problem. But the idea is for it to operate essentially autonomously and let you know when it's corrected a problem rather than wait for an operator intervention to correct it. So in addition to adapting to network changes, ScriptEasy, of course, can also function on operator input. You can click a button and cause the ScriptEasy in one codec to send commands to another codec, to change profiles, to establish a different link, to insert some local content, to change from the analog to the digital input. Basically anything you can do on the codec, you can trigger remotely using this SNMP, and if you choose, you can trigger it using another codec as the actual controlling device. So this whole concept of distributed intelligence means that you don't have to put your facility control eggs into one basket anymore. You can, and of course, it's a good idea to have kind of one centralized place where you can see all the information. But the brains of the operation don't have to be focused on one piece of hardware. You don't have to have that single point of failure. If your remote control unit goes down, or it's just difficult to wire it into all of the things that you need to wire it into, the codecs and the other devices can actually have a little bit of functional intelligence so they can handle sort of their part of the world autonomously and then interface with a more managerial type piece of equipment or piece of software at a higher level to contribute to the overall station status indications. All right, then packet forwarding is going to be where we're going to bring in my friend Kevin Campbell, my colleague from Belfast, Northern Ireland, and he's going to talk about another one of the building blocks in the ultimate IP audio network, and that is the concept of packet forwarding. So Kevin, it's all yours.
Okay, thank you for that, Tony, and I hope everyone can hear me there. Okay, so packet forwarding. Packet forwarding we've developed really to complement what we're doing with SureStream and ScriptEasy in building this ultimate IP audio network and increasing the resilience of IP networks. In terms of what it is, it's a similar concept to drop and insert. I'm sure a lot of our listeners are familiar with T1, E1, either on the 3U Oslo that we've had around for a number of years and also on the Interplex unit. Basically what drop and insert allowed you to do was to take time slots and pass those time slots to decoders within a frame and then groom those time slots across to a secondary T1 to create ring topologies and spoke networks and so on and so forth. And drop and insert was very effective as a synchronous technology on T1 in feeding multiple decoders. And the issue with drop and insert was it was quite static. You set the configuration and then you forgot about it. It wasn't really dynamic. With IP and packet forwarding, it's much more flexible. So we're able to pass packets to decoders, and any decoder can essentially become a backup audio source. So packet forwarding relies on two things. First of all, distributed intelligence. So each decoder needs a script-easy license, which is included in all our decoders now, to interpret a problem and take an action. And of course, each decoder needs an alternative network path. So if you're going to receive audio from another decoder on the network, then you have to have that decoder have a path to an alternative decoder. So let's look at some theoretical example here to see how packet forwarding can work. So in this example, we have a Miami studio sending audio in SureStream to three decoders: Tampa Studio, Miami Downtown, and Miami Key West. If we have a complete failure on both component streams, let's say into the Tampa Studio, or sorry, into the Miami Downtown and into the Miami Key West, then we can use script-easy, which is residing on both of the Miami codecs, to call for the packets from the Tampa Studio. So in effect, the decoder, which is still connected to the Miami Studio, has now become the encoder for Miami Downtown and Miami Key West. And that's through packet forwarding protection. Crucially, when we use packet forwarding protection, there's no encode-decode cycle. So if you're using a psychoacoustic algorithm, you're not suffering the penalty of encoding and re-encoding the audio, which can, of course, introduce artifacts on a psychoacoustic algorithm. So let's look at a further example. In this case, we're doing STL Path Protection. So again, we're SureStreaming from a central site to two geographically diverse transmitter sites, A and B. From the studio, two component streams for SureStream. In this example, we lose one of the component streams. Script-easy as a distributed intelligence. Remember, that's important. Script-easy lives on each codec, each node within the network, so we don't have a single point of failure with a central watchdog. It's distributed throughout the network. So we have script-easy looking at the component streams, seeing that component stream with the red dotted line into transmitter site A has died. It will reload a profile with the same settings for component stream B and take the second component stream from the decoder at transmitter site B, thereby restoring the full SureStream protection into transmitter site A. And that's all done using script-easy and the packet forwarding. So again, there's no additional encode-decode cycle while the audio packets traverse transmitter site B onward to transmitter site A. What script-easy will also do is monitor the original port where the component stream, the original component stream A is coming in from the studio, and re-establish the original profile in the event that the audio packets start to flow on that second component stream. That can all be done using script-easy and packet forwarding without glitching the audio. And again, what you're relying on is script-easy to monitor the health and the status of the network. That can be done by loss of connections, that can be done by drop packets, could be done in a disaster scenario by looking at silence detect, and then you're relying on diverse paths into different decoder sites which can then take over and act as the encoder. In this second example, we have decoder redundancy. So this is a single transmitter site, and here we've got two decoders. So we've got network protection, we've got two networks on A and B, and then we've also got two decoders. So each decoder is receiving in SureStream, again, for network protection, but in the event of a complete failure of either of the networks or of either of the codecs, we have the ability to traverse the dead or powered down codec and still get to the transmitter using a cable modification and a contact closure. And again, this is all governed by ScriptEasy, living on the decoders, distributed around the network. So we don't have any single point of failure in terms of the watchdog capabilities of ScriptEasy. This is the project that we did for the NBA. Basically, they had 40 plus sites around the country. So the encoders, so it was about gathering the audio in, live feeds for home and away commentary of each game. So they had 40 locations, stadiums, and the flagship radio stations themselves. That audio was transported, 42 streams in total, back to the head end, which is in Secaucus in New Jersey. What they wanted to do there was decode the audio, archive it. Secaucus is the, you can say, the central repository for all of the video and audio content related to the NBA. But what they also wanted to do, as well as rebroadcast that, was send it on to Akamai content delivery network, and then that was passed on to the parent station Turner Broadcast. Using ScriptEasy, we were also, and packet forwarding, again, we were also able to do very quickly a very novel monitoring application. So basically, each of these 42 streams, they wanted to monitor the content to make sure that the affiliate or the flagship at the far end around the country was feeding the correct audio into the encoder. So rather than getting the rock format or the classic format, they wanted to ensure before the game started very quickly that each of the 42, well, each of the feeds that was live in that particular game night was in fact the correct audio. So using ScriptEasy, we were able to give them a representation of their network where they were able to packet forward to a dedicated decoder and then orally listen to the commentary to make sure it was in fact correct. So packet forwarding together with ScriptEasy provides a very powerful tool in terms of redundancy and in terms of monitoring what is happening across your IP audio network. So fourth component in all of this ultimate IP audio network, packet forwarding, SureStream, ScriptEasy, multiple Unicast or Multicast relocation. So what's that about? First of all, a quick definition. Multicast and multiple Unicast, really one of the key, let's say, benefits of IP as opposed to synchronous technologies. If we look back, E1, T1, it was a lot more rigid, a lot more inflexible in that you had to assign time slots. You had to groom time slots across between dedicated E1 or T1 circuits. If we talk about ISDN, it was strictly point-to-point. You could do dual mono to make point to 2-point, but that was effectively it. With multicast or multiple unicast, if you've got the IP cloud between sites, you've got enough bandwidth, you can basically hit as many endpoints as you need. So multicast is basically deployed on a private network. It uses the ITM protocol. Decoders join and leave groups, and you can have an unlimited number of decoders. So it's not related to the open internet, it's related to private networks, WAN, LAN, MPLS, and by that nature it's more expensive. Multiple unicast, on the other hand, can be used on the open internet. The replication of the packets in this case happens on the encoder. Because it happens on the encoder, a limited number of decoders can be reached as we are dependent on replicating the packets on the decoder, and there is an infinite amount of processing power and bandwidth in any encoder we're also limited to the bandwidth into that encoder. So that's the definition. Summary: multicast for private networks, multiple unicast for the public internet. So in developing SureStream, the SureStreamer script easy packet forwarding, we came across the idea of, you know what, the multicast or the multiple unicast function of an IP codec does not necessarily have to live in the same place or reside where the actual audio coding takes place. What's the benefit to that? Well, if we relocate where the multicast or multiple unicast function happens, then we can manipulate the telco costs. So in doing that, we think we have an alternative to expensive satellite delivery for syndicated content. So here's an example. In this case, we have an encoder in Florida. We have a small number of affiliates who want to receive that content in California. So we place the SureStreamer in, let's call it, the decode market, i.e. in California, closer to the decoders. We then feed the decoder with an MPLS stream, or sorry, an MPS component stream, and also a DSL component stream. So we're SureStreaming into the multicast node, which is the SureStreamer. So if we have a failure in MPLS or we have a failure in DSL, the packets are still arriving. Our multicast network is still being fed with audio. And if we look at how we could do that traditionally, we would have to feed the multicast network with 4 MPLSs. So from here, 4 MPLSs to each of these 4 decoders, which are in 4 different Californian cities, and then 4 DSLs. But now we have 1 DSL to the node provided by the SureStreamer and 4 short-haul MPLSs. And by doing that, we reduce the cost from 6,200, which is 1,500 national MPLS circuits plus the ADSL, to 4 local MPLS circuits, much cheaper, plus the 1 national MPLS circuit, which still needs to feed the SureStreamer, which is our multicast node. So we reduced our cost by relocating where that functionality, multicast or multiple unicast functionality, is happening. By relocating that functionality, we've reduced the telco cost by 43%. If we upscale that to 10 decoders in the Californian market, we reduce the cost from $15,500 to $7,000 US, a reduction of 55%. So by doing that, you can see that we can quite easily achieve a very big saving on telco and link costs. So if we put all of this together, we can see in our Ultimate IP network, we've got Florida as let's say the main place of broadcast. So we've got our Miami studio, and here we've got protection on the encoder, which is also important. Again, that's governed by Script Easy. We need protection on the encoder because we've got so many units downstream of that single encoder that if we have a hardware failure on that, it's a disaster. So we have to have encoder protection. We have that. We then have SureStream protection into each decoder. So could be cable modem DSL, could be MPLS DSL. Again, we can use different components, streams, in terms of different telco links, dependent on cost, dependent on the importance of each decoder. So it could be dual DSL, could be dual MPLS even. We have customers using all types of networks to achieve SureStream reliability. So we have SureStream reliability. What if we lose both component streams into Miami downtown? Well, we've got packet forwarding protection. because remember, each decoder has a script easy living inside, which is always monitoring parameters that you set, you configure, and it knows if it loses both component streams, it will load a profile to look for the audio feed or the packets from the Tampa studio. If they're not on the Tampa studio, it could then move to a second profile where it looks for the packets from the Miami Key West studio. And the great thing about this, remember, is that Script Easy is a scripting tool. Many of the iHeart engineers know this tool on the Relio product in the US in particular. We can put this power in your hands. It's not something that you need APTs R&D to do. It's a scripting tool usable by the engineers, so all sorts of scenario and configurations can be built up. So if we look then at our affiliate network, which is out in California, we're using our SureStreamers here to relocate the multicast or the multiple unicast functionality away from the encoder, because it no longer becomes necessary to have that as part of the IP codec. We do that to reduce costs, of course. From the SureStreamer, we are protecting with SureStream each of the affiliate codecs. So again, it could be DSL MPLS, could be DSL DSL, or it could be DSL microwave, whatever. We don't mind what component streams you use, or it could be a single stream if you're prepared to pay for the single MPLS and it's reliable enough. So we've got affiliate protection and resilience there as well. Of course, we can also protect this node. So should this node fail, or should the network fail into this node, then the backup node can be loaded with the profiles to feed the affiliates. Again, Script Easy, living on the SureStreamers, is controlling and monitoring and making those decisions independent of the engineer. Also important to note, while all of these switching actions are happening, Script Easy can send emails, notifications, and there's an alarm log that's built up to let you know, time-stamped, exactly what has happened and exactly what actions have been taken in your absence. So the other thing, we can of course monitor, this node can monitor the network, and when it's restored, it can flag to this node that the connection should be dropped, and we can return the original configuration as was. Why you want to do that? Perhaps you've got a tariffed IP bandwidth here, or you're sharing this with data services for your station, and you want to get off the backup and onto the main again. So again, governed by SureStream, controlled and monitored 24/7 in real time. So in conclusion, once you put together encoder protection on the Miami studio in this example, because we've got now 1, 2, 3, 4, 5, 6 decoders hanging off this encoder, you must have encoder protection, which is governed by SureStream. You should have protection, SureStream protection into all of your links. Well, it's not necessary if you're prepared to pay for more expensive links, but this is DSL and cable modem in some of these examples. We also have packet forwarding protection should the path to the main encoder become unavailable for some reason. So again, any decoder within the network can act as an alternative source or encoder for any other decoder if you programmed it up that way. We've then got affiliate protection down here with dual nodes, main and backup, and from each of these nodes we again are running SureStream to each of the affiliates. So there's absolutely no single point of failure, and we can use MPLS right down to DSL and cable modem, whatever type of IP bandwidth you want to throw at this. Remember, as Tony showed you earlier, we had 160 days without a drop packet between Belfast and Miami using DSL and cable modem. So we have a very reliable way of getting audio from point A to B, and then we've layered in intelligence with ScriptEasy on top of that, plus the packet forwarding to mean that any decoder can look to any other decoder for audio. Plus we also have the ScriptEasy, which is the watchdog, distributed intelligence watching it all. Finally, the last IP audio considerations, or I should say supplemental IP audio considerations, take care of the coding. We're still strong believers in enhanced aptX. It's essentially a lossless coding scheme. You can do multiple encode decodes if you're forced into doing that, and it won't affect the integrity of the audio. It won't introduce artifacts into the audio. Look for reliable hardware. PC-based architecture is fine within the broadcast chain for monitoring and some other functions, but for audio streaming, for something that's processor intensive, that needs to churn away 24/7, 365 days a year, we say DSP, and we say modularity and redundancy at a head end if you're encoding and you've got lots of decoders hanging off that head end. Contact closures and local content insertion functions, important, especially if you're looking to this technology as a replacement for syndicated content distribution. Control is important if you're receiving emails from your ScriptEasy watchdog to say, yeah, there's an issue here, you need to get into the unit. The user interface should be web-based, so you can get in from your iPad, from your iPhone, whatever device you have to hand, and quickly. And choose a reliable partner. If you go down this route, you mightn't have, you won't have an SLA with a DSL and a cable modem type configuration. You will still with an MPLS, but you need someone who knows how to script, how to build up backup scenarios, and how to support you in putting together these very cost-effective networks using whatever bandwidth is available to your transmitter sites and between your studios and your affiliate partners. And I believe that Tony, that's it from me. I believe Tony and Gillian have been curating your questions.
Yes, we have acquired some commercials or some questions that we have gathered through, and I'm going to toss a couple of these at you here, Kevin, if you're ready.
Great.
All right. First question that we have is, why is SureStream on a single link, or how is SureStream on a single connection better than FEC?
Oh, okay. Well, FEC will give you protection within a defined array. So if you've got a 5x5 array and you stray outside the parameters of that 5x5 array, then you don't have any protection. It's gone. With the SureStream on a single port, we have a diversity generator which is scalable. So you have a number of different settings on the decode side, which allows you to introduce diversity into the packets that you're emanating onto the network, and that will give you more redundancy than the typical FEC scheme.
Okay. I think FEC, if I'm not mistaken, also adds some delay into the link too, does it not?
It does. It does. It will add more delay than any of the diversity settings that we would implement on the decoder side. That's for sure.
Okay. Second question, with the packet forwarding, does it require the same information is being sent to both sites, or will it go all the way back to the source and reroute the path? Well, that I'm going to have to, I'll contact that customer. I'm not quite sure I understand that one. Another question, how long does it take to switch when you lose connectivity? I think I'll take this one here. I think if we back up just a little bit, we need to understand there's a difference between, for example, if you're talking about the redundant stream, like these two redundant streams going from this studio to this studio, when you're talking redundant streaming, that's SureStream protection, and there is no switching, is the short answer. It's like the packets are all being played, so if one of these links fails, and you've got redundant streaming established, there is no delay, there's no audible, there's no switching. It just continues to play out the audio. If you're talking about the switching of links, for example, if the main link gets interrupted to downtown here, and then you have to establish a different profile to forward the packets through here, that is going to cause an audible interruption. Obviously, you will have lost the link to the Miami downtown codec to begin with. So the delay on that is just going to be essentially whatever you program into the script.
Correct, and that's important, Tony. It's an important distinction. I'm glad that question has come up because SureStream is what we call always-on redundancy. So we're receiving both copies of the packet into the decoder simultaneously, and if you have a failure on either of the component stream, there's no timeout, there's no primary backup or primary or secondary backup scenario. So it's always on redundancy, but yeah, you're also right in saying that when we do the packet forwarding, by necessity, we have to have a countdown, which is completely configurable within the parameters of ScriptEasy.
Okay, fair enough. And then we've got one other question about sending audio. Hang on a second, let me get to the gist of this here. What is the minimum internet speed for communication?
The minimum internet speed, well, again, completely configurable. Within our codecs, we have linear PCM at 24-bit. You're talking 2.2 megabits per circuit, or sorry, per stereo with packetization, and then you can go right down to ASC high efficiency, where you're talking 24 to 40 kilobits per stereo. Typically, what we see with the majority of our customers who come to APT for audio codecs is they want to use the enhanced aptX algorithm. So 15K stereo relates to 256 kilobits in synchronous world. With packetization, that relates to about 320 kilobits using a 512-byte packet size. So majority of our customers, stereo FM delivery, 320 kilobits, HD delivery for 22.5K frequency, about 520 kilobits per stereo feed. Okay.
So the short answer is yes. Whatever the bandwidth you have, there is some algorithm that will likely get some audio through it. Also, just one last final question about NPX over AES. Yes, we do both AES and analog NPX on our products now, all of which can be SureStream.
AES and analog currently on the AOIP card. To be defined on the APT IP codec. Currently in the APT IP codec, it's AES. On the AOIP card, it's AES and analog available today.
Okay, super. Good to know. That's really all the time we have. Thank you, Kevin.
Thank you, Tony.
Thank you, Jillian. Thank you, everyone, for attending. I can still see we have a lot of people still online that stuck with us through the whole thing, so thank you very much, and I would like to encourage you, everybody, again, to visit us at NAB in North Hall, booth 6134. Give us a call if you want to set up an appointment so you can talk to the people that you need to talk to, and then Tuesday night we're celebrating not only a brand new 10 kilowatt transmitter, which is awesome, but also 60 years of building transmitters with our Acrezo division, so a great celebration, and we're looking forward to seeing everybody at NAB. Thanks to all for attending. Thanks to Jillian McDowell, our Communications and Marketing Director, for helping to organize this and keep Kevin and I more or less on track. And we'll hope to see you all at NAB here in a couple of weeks. Take care.